Alright, we will have a quiz next class about Solow growth model.
Oh my gosh, EQ and boss, I don't understand about capital accumulation.
Alright, I will explain it to you. The production is used as the analysis will be as follows. Y is equal to the function of k and n, which k is capital and n is labor. In this case, we will assume that the constant return to scale occur. Constant return to scale occur when increasing the number of inputs leads to an equivalent increase in the output. So we divide the function by n to make the production function to the production function in term per worker. Next, goods market selling condition. In this condition, the function we have I equal to x plus by t minus g, which I is an investment, S is saving, and T is tax. In this situation, we assume that G and T are equal. Therefore, in this condition, investment will be equal to saving. For saving function is S equal small s multiplied by, which S is saving, small s is the saving rate, which is the proportion of saving from income, and Y is income or output. Because the saving function is including output, when the output or Y increases, it will make the investment increases. Therefore, investment depends on output. Next to investment and output in per worker. To calculate the investment and output in terms of per worker form, we use the function of I equal to small s times Y. We divided the function by capital N. According to the production function, small y is equal to the function of k. Hence, I divided by n equal to s times y divided to the form of capital per worker, which is I divided by n is equal to s times function of small k, which small k comes from k divided by n. For investment and output graph, the y-axis is output per worker and the x-axis is the capital per worker. The curve of output per worker represents the diminishing return to scale. We all know that I is equal to S, but in this graph, there is a proportion of saving rate or small s that make the S times function of k curve less than function of k. Move to depreciation. According to the graph, delta is the rate of depreciation, which is the proportion of the capital stock that wears out each period. And delta times small k represent depreciation of capital per worker. When the capital increase, the more depreciation increase. Now we move forward to the capital accumulation. We will look at the equation k prime equal 1 minus delta times k plus I. The equation states that capital in the next period equals to the undepreciated capital stock plus new capital stock put in place during the period, which 1 minus delta times k is the capital stock remained intact from 1 year to the next after deducting depreciation, and I, which is the investment during the period. When we consider about per number of workers in the economy, we do so by dividing all terms in equation by per worker or the capital N. We get k prime over n equal to 1 minus delta times k over n plus I over n. Then we get small k equal 1 minus delta times k plus s times y. Since I is the saving rate times output, finally we get k prime equal 1 minus delta times k plus s times function of k. Since y equal function of k, it means the capital per worker in the next period equal undepreciated capital per worker plus investment from this period. Now we will talk about the change in capital stock per worker. It is derived from our previous equation. The equation is delta k equal k prime minus k equal s times function of k minus delta k. Delta k is the change in capital stock per worker. If investment is more than depreciation, capital stock will increase. If investment is less than depreciation, capital stock will decrease. Here is the graph showing the relation of output per worker and capital per worker. When the change in capital stock equals to 0, or when we say S times function of k equals to delta k. Alright, that's all I can explain. Boss, do you understand about convergence to steady state?
Yes, I do. Now let's see how to converge to steady state. According to the graph, if we assume that we are in K1, it means that investment is more than the depreciation. When time passes, it will gradually move back to steady state, which means that investment is equal to depreciation or at K star and Y star. Next, we will do a time series plot for capital per worker and output per worker. Figure A illustrates time series plot for capital per worker, and Figure B illustrates time series plot for output per worker. We need to know that output per worker and capital per worker are constant at steady state. If we assume that economy starts with too little capital, output per worker and capital per worker will grow, like you see on the figure A and B. Let's move to the next topic. If we assume that we increase saving rate from S0 to S1, it will shift the investment curve upward, which change K star 0 to K star 1 and Y star 0 to Y star 1. In conclusion, increase in saving rate lead to an increase in steady state. But we still don't understand about golden rule level of capital stock. Can you explain it to us?
The topic of golden rule level of capital stock. K star G is the steady state value of K that maximize consumption. For the formula, form saving equal to income after tax minus consumption. Next, we will make it in terms of per worker form by divided all term by n. And in the steady state, saving equal to investment and equal to depreciation rate. So final form of equation be like consumption per worker equal to function of K star minus delta K star minus T over N. Next, for the graph, the point that has the maximum gap between two curves will give you the level of K star T. The last one transition to the new steady state. For the graph of output per worker over time, first it starts with too low saving rate, so steady state is low 2. After we increase saving rate, steady state will increase too. So output per worker will gradually move to the new steady state. For the graph of consumption per worker over time, first it starts with too low saving rate, so the steady state is low too. But after we increase saving rate, steady state will increase, so consumption per worker will gradually move to the new steady state. At TO, consumption decrease because we will consume the remaining after saving, so that's why consumption drop at TO. For the graph of investment per worker over time, first it starts with too low saving rate, but after we increase saving rate, steady state will increase, so investment per worker will gradually move to the new steady state. At TO, there was a jump in the investment because increasing in saving lead to increase in investment.
Thanks, Earn.
Yes! We are already to quiz